So today we're going to be going over factoring. Now, factoring is often a troubling subject for students because I think generally they don't understand the process of what we're doing. We do understand the process of if I have something like, let's say, 2, and I want to distribute it to an expression, let's say 10 minus 3x. When I distribute a term, we're taking this term and we're multiplying it times everything on the inside, which would mean that my resulting expression would be the equivalent of a 20 minus 6x. All factoring is taking the process and going in reverse. So if this is distribution, then this is factoring. We're undoing the process, we're undoing the distributive property. So I would take this and I would say, what can both these numbers be divided by? Well, looks like both these numbers can be divided by 2, which means I'm going to pull out a 2 and see what I have left. That would leave me with a 10 minus 3x. And so, in essence, distribution and factoring are opposites. Now what we're looking at today is we're trying to take a polynomial expression and turn it into a binomial. What, in essence, has happened with today's subject is we've had somebody go in and say, hey, let's take something like a 2 plus y and then a 3 minus x. And they've distributed not one term, but 2 terms into this. So if I were to, let's go ahead and separate this off. If I were to distribute the y into both these terms, y times 3 is 3y, y times negative x is negative xy. I would then have to go through and distribute the 2. So I would take 2 and multiply it times both those terms. And I'd be left with, let's see, that is a 6 minus 2x. And then my final answer would be arranging these 4 terms in alphanumeric order, which in this case would be a negative 2x minus xy plus 3y plus 6. And that would be my answer. That's distribution of a binomial. What we're trying to do is take this and reverse it back up. So if I wanted to take this expression and reverse it back into the original, what I would have to do is I would have to figure out what the 2 common factors are. This had a factors of y, this had a factor of 2, and I need to be able to spot those. So this, I would take the left 2 expressions. I would say, hey, they share a factor of a negative x. These 2 expressions over here share a common factor of 3. So I would go through the same process that we did earlier where I pull them out. I would say negative x, what do I have left? I would take the 3 out, what do I have left? Over here, if I pull that out, I would have a 2 plus y. Over here, I would have a y plus 2. Because both these are the same thing, I will again pull out a common factor and say, how about I pull out a y plus 2? And if I do that, I'll pull out the y plus 2 off to the side. And what I'll be left with is I'll be left with a negative x plus 3, which if we can see the fact that that is the same expression that we had originally. So when we factor a polynomial with 4 terms, you just pull out both GCFs. In essence, you're pulling out both the terms you just distributed in. And then you'll notice you'll have a term left over, which will give you binomial A, and what's left over is binomial B. So that's the idea behind what we're going to do today. So let's check out a few examples. So with number 1, what we see is that I have only x variables here. But again, we've already discussed the process is not going to be any different than what we've done before. The first thing that we notice is when we want to factor each expression completely, I'm going to pull out the GCF out of the left 2 terms. I'm also going to pull the GCF separately out of the right 2 terms. Because I have 4 terms, which means I must have had a binomial and a binomial. I got to figure out what was distributed to these 2 and what was distributed to these 2. So with my first one, it looks like I have both 24 and 6 are divisible by 6. X cubed and x squared are both divisible by x squared. So I'm going to pull that out and say 6x squared. what's left over? Well, 24 divided by 6 is 4, and I have a single x left over. 6 divided by 6 is 1 with no x's, so I'm just going to put minus 1. Over here, I'm going to say both these are divisible by 2, so I'm going to go ahead and pull out the 2 and see what I have left over. In this case, I have a 4x minus 1 as well. Because they both have a 4x minus 1, both this term over here and this term over here, I can pull out the 4x minus 1 just like what I did. Pulled out a 6x squared, pulled out a 2, I'm going to pull out the 4x minus 1, which leaves me with 4x minus 1. Then I'll have a 6x squared plus 2. The last step that we're going to have to do is we notice that both of these are divisible by 2. So you guessed it, I'm going to go ahead and I'm going to pull out a 2. So if I pull out a 2, what's left is going to be, let's see, 3x squared plus 1, 4x minus 1, and that is our completely factored expression. Again, it's just a lot of division. All factoring is we're checking what can we divide, what can we divide, what can we divide. Once we've divided by everything possible, we're done. So let's go ahead and try another one. With this one, I'm going to do the exact same process. I'll say, what can I divide over here? And then, what can I divide over here? Now, with this one, what you're going to notice is the fact that I'm leading with a negative. So this is going to mean something different is going to happen, but we'll see about that here in just a moment. I go through and I say, what can 4 and 2 both be divided by? They can both be divided by 2. I'm going to say, with y cubed and y squared, I can divide by a y squared. So I'm going to go ahead and pull that out. So 2y squared. Let's check what we got. That's going to give me with a 2y plus 1. So oftentimes when students look at this, they'll say, hey, how about I pull out, in this case, there's nothing that's similar, so how about I just pull out a 1? So they'll put plus 1, and they'll go through this, and they'll say, well, this is a negative 2y minus 1, and they'll notice that my two expressions are not equal. So they'll say, oh, nope, can't do it. But what I notice is that I have a 2y and a 2y, a 1 and a 1, but between the two terms, the signs are wrong. So all I'll do right here is I'll pull out an additional negative 1. And so when I pull out the negative 1, I'll have a positive 1 times negative 1. And then I'll have my general expression. This will now become a 2y minus 1. This over here stays exactly the same, so 2y squared, 2y plus 1. And now at this point, I see that both expressions have a 2y plus 1. So guess what? I'm going to be able to factor that out by saying 2y plus 1. 2y plus 1, pull it off to the side. Right here I have a 2y squared. 1 times negative 1, because I pull that out, I have to multiply the two of them together. 1 times negative 1 is going to give me negative 1. And that right there is my final expression, because as I'm looking at it, I can't divide either of these by anything else. Awesome. So how about you go ahead and you try this one on your own? Pause the video, unpause it when you're done, and see how well you did. Perfect. So now that you've had a chance to try it out, let's see, our GCF over here is going to be a 4y squared. When I divide them both by 4 and remove 2 y's, I'm left with y plus 2. Over here, I can divide them both by 3. And when I divide out the 3, I'm left with y plus 2, which leaves me with a new common factor of y plus 2. So I have y plus 2, if I can write that 2. There we go. And then I have 4y squared plus 3. And there we go. Perfect. So now that's going to bring us to the second part of our sheet. So let's take a look at number 7. Perfect. Okay. So with this one, we have larger numbers, and oftentimes students might get a little intimidated where they say, okay, what if I don't recognize what I can pull out that's the greatest? How would I handle that? Well, let's say we notice both these are divisible by 6. Let's say we don't notice they're divisible by 6, but let's say we try instead for a 2x squared. How would we handle that? What would it look like? Well, if I pull out a 2x squared, I would have, let's see, 66 divided by 2 is going to give me 33x. If I pull out a 2, I'll have minus 18. Then over here on this side, I'll notice, okay, they're both divisible by 5, so I'm going to pull out a 5, see what I get. It's going to give me an 11x minus 6. So what we notice is the fact that my two expressions are not equal, but I still have a GCF over here. So what I'll do is I'll just repeat this process again and say, can I pull out another common factor? Well, in this case, I can pull out a 3, which means I'll have my 2x squared, but now I'll also be multiplying it by 3. And let's see what we have left. So I've pulled out the 3. It's shown up over here now. And I'm left with 11x minus 6. Ooh, and that's good news for us because, lo and behold, the expression over here is also 11x minus 6. And because this and this are the same, I can again divide this out as a common factor. So I'll pull out the 11x minus 6. And then what's left is I'll simplify this piece right here. So 2 times 3 will give me a 6x squared plus 5. And then a quick double check. Do we have any other common factors left? Nope. So therefore, that's my final answer. So even if you don't spot the greatest common factor, just realize you'll have to do an extra piece right here, but it'll eventually settle its way in. Awesome. Now, what happens if upon first glance they don't work out? You'll notice with this one, if I try and pull out a GCF right here, I'll have a 3. So I would pull out the 3 and I'd be left with z cubed minus 2. Over here I could pull out a z, so plus z. I'd have 2 minus 9z. Those don't equal, there's no common factors. A lot of people would say done, does not work. So does not compute. I'm not sure if there's an expression for that. Does not work. So quit, done, throw in the towel, let's move on. But take a look at what's going on here. We have a z cubed, followed by a constant, followed by a z, followed by a z squared. One of the things you'll hear often in specifically a math course is they'll talk about alphanumeric ordering, which basically means put the terms in the right order and things tend to work out a little easier. So let's get rid of all this because this actually does compute. There we go. And alphanumeric ordering means I'm going to put them in order from highest to lowest power, which means that this term is going to come first, this one's coming second, third, and fourth. Z cubed, squared, first, no z. Perfect. And now let's try this again. Now that it's in alphanumeric order, if I look at the first two terms, I can pull out a 3z squared. So 3z squared, and I'm left with, let's see, what is that? A z minus a 3. If I look at the right two terms, I'm going to pull out a 2, which leaves me with a z minus 3, and boom, magically it works now. So remember, if you're looking at an expression and the numbers aren't in alphanumeric order, most of the time it's going to work out pretty easy if you put them back in the right order. If I put them in the right order and it still doesn't work, it might be something that we need to apply the rational root theorem to, but we'll cover that in a later section. So let's just go ahead and finish this one out by saying I'm going to divide by z minus 3. Get rid of those, so z minus 3 is on the outside. That's with 3z squared plus 2. Nothing common left over, so I'm going to go ahead and call that my final answer. There we go. So let's move off into the last question. So this one has no constants. So why don't you pause the video, give this one a shot, apply the same principles, and don't worry about the fact that you don't see any constants, any numbers, and see how it works out. See if you can't get to the answer. Unpause the video when you're done, and let's check and see how you did. Okay, so now that you've had a chance to try this out, let's give it a shot. So over here I have an AC and an AX. I'm gonna start this out and see if it works. I notice they both have the variable A, so I'm gonna pull out the variable A, and let's see, with no A I'm left with a C, with no A I'm left with an X. Over here, it looks like they both have the variable Y, so I'm gonna pull out a Y. And I have what looks like a variable C and a variable X. Boom. So they both have C plus X. So C plus X over here. And then I have A plus Y. No common factors here. So there's my answer. Here you go. So how'd you do? And that's how we factor. There you go.